When developers build a new artificial intelligence model, they start in a completely isolated laboratory environment. Inside that controlled space, the code is pristine and the inputs are entirely predictable. But that pristine logic shatters the moment it encounters the real world. When you expose a clean, highly theoretical coding assistant to the erratic logic of actual human developers, it immediately breaks down. To bridge that gap, engineering teams rely on a crucible phase. They set up a structured collision, intentionally throwing an unproven AI model against actual human ingenuity to force it to fail. True intelligence in a coding model cannot be purely programmed in isolation. Its reliability must be stress-tested into existence by its end users. That vulnerability to real-world chaos is exactly why the highly anticipated K2.6 code preview model was sequestered from the public prior to its launch. We see this containment zone in this official 2026 message. Access was restricted to a cohort participating in this session of the Kimi Code beta program. These earliest testers pushed the K2.6 model beyond laboratory constraints to expose its weaknesses. This restricted access created a mandatory operational quarantine. The engineers required a closed environment to locate the model's breaking points without disrupting a wider user base. Eventually, that period of active, real-world testing reaches a definitive conclusion. As the bold text at the top of this document states, the beta program session ended. Shutting down the beta program triggers the next major phase of the development cycle, a massive data synthesis operation. The development team now faces the task of categorizing and analyzing every single raw input, error log, and correction generated by those early users. Every individual syntax error report and manual user correction is quantified into a master dataset. The development team harvests the collective intuition of those human testers, baking it directly into the AI's foundational logic to permanently train the system. This structured database of user intuition drives a period of intense, behind-the-scenes engineering. The Kimi Code document confirms this process directly, stating, "We're making final improvement based on the feedback we received." During these final improvements, engineers surgically excise the flawed pathways exposed by the beta testers, while simultaneously reinforcing the logic models that performed successfully under pressure. The initial beta model was raw and vulnerable. The version being compiled in this final stretch is refined and hardened by thousands of hours of real-world friction. As a result, the K2.6 code preview model is a direct hybrid of original code and community-driven corrections. With that mandatory period of isolation and refinement complete, the model finally stabilizes. It is ready to face the open market. Because of that stabilization, the refined AI can finally break out of its closed beta restrictions for general availability. We see proof of this imminent mass deployment in the final paragraph. The text promises that the K2.6 code preview model is about to roll out to everyone. Transitioning an AI model from a controlled beta environment to a public rollout represents the final threshold of confidence for the engineering team. Previously, this tool was restricted to a select few. Going forward, it becomes a standard utility for developers everywhere. This launch marks the point in the 2026 timeline where the Kimi Code ecosystem moves past isolated experimentation and into public utility. While this specific beta iteration has concluded, the community architecture established there guarantees future cycles of testing, input, and engineering refinement. The rollout of the K2.6 code preview demonstrates that for AI to work reliably in the real world, it must first be broken and rebuilt by the people using it.